Hello everyone. In this presentation, we'll be learning about enzyme kinetics, some germinal terminologies of chemical kinetics and enzyme activity. Enzyme kinetics. Enzyme kinetics is nothing but a quantitative study of enzyme catalysis. That is, we are studying here the reaction rate. That is, how fast the reaction is moving forward. Enzyme kinetics also help us to find the affinity for given enzyme for given substrate. Suppose we have a given enzyme, and is it showing the affinity for the given substrate? That can be found out with the kinetic study of that enzyme. Similarly, is that enzyme being inhibited by the specific inhibitor? That can also be found out with the kinetic study of the enzyme. General principles of chemical reaction is also applied for enzyme catalyst reaction as well. Now consider a very simple reaction, that is these are the reaction A and B are the reactant which is being converted to product. Now the rate of this reaction can be expressed as change in concentration of A with respect to time, change in concentration of B with respect to time, and change in concentration of product with respect to time. Now A is decreased, means A is being used up in the reaction, A and B are being used up in the reaction, and P is product is being formed. So negative sign indicate that the rate of disappearance of A, negative signs rate of disappearance of B, and here product is formed, so rate of appearance of product. So rate can be expressed as rate of disappearance of A, the rate of disappearance of B, or rate of appearance of product. Now A is the delta A is nothing, minus delta A it is showing, but change in concentration of A with respect to time. Now A concentration is expressed here in moles per liter. Okay. Now let's understand what is an order of a reaction. Now here rate, let's say rate is directly proportional to the concentration of A into concentration of B. A, B are nothing but your reactants. Now if you want to report the proportional side, rate is equal to K, that is K is nothing but a rate constant into concentration of A into concentration of B. Now F and G are your exponents. Now exponents, the value of exponents can be determined experimentally. Now the value of these exponents, they are not necessarily equal to the coefficient of your balance equation. They are not always equal to the coefficients of your balance equation. Their value is such a whole number such as 1 or 2, and value of exponents is related to the number of molecules involved in detailed step. The value of exponents is related to the number of molecules involved in the detailed step. Now overall order of a reaction. Now this is a rate equation. Okay, rate equation for a reaction where A and B are your reactant. Now order of this reaction will be F plus G. So overall order of this reaction will be F plus G. The overall order of a reaction is sum of all exponents. Now let's understand first order reaction. Let's consider a very simple reaction where A is a reactant which is being converted to product. The rate equation will be rate is equal to K into concentration of A raised to 1. Now K is nothing but your rate constant, and K, 1 raised to 1, that exponent is 1. So you can say that the reaction is first order with respect to A, and only one exponent is present. So you can also say that the overall order of this reaction is first. The reaction is first order with respect to A, and overall order of this reaction is also first. Now let's understand second order reaction. Let's consider a simple reaction where A and B are your reactant which is being converted to C and D. The rate equation will be equal to rate is equal to K rate constant into concentration of A raised to 1 and into concentration of B raised to 1. Now 1 and the raised to 1 is nothing but your, these are the exponents. Okay. The exponent for the concentration of A is also 1. The exponent for the concentration of B is also 1. That the reaction is said to be first order with respect to A. The reaction is also said to be first order with respect to B. But the overall order of this reaction will be sum of the exponents. Okay, the overall order of the reaction is 1 plus 1, 2. The overall order of the reaction is, it is second order reaction. But with respect to the concentration of A, it is first order. With respect to the concentration of B, it is first order. But the overall order of the reaction is, it is second order reaction. Now let's understand what is a zero order reaction. Let's consider a simple reaction where A, your reactant, is being converted to product B. Now rate equation for such reaction will be rate is equal to K, rate constant, into concentration of A raised to 0. Okay, so rate is equal to K. Okay, so here since exponent is 0, the order of the reaction is 0. Now what do you mean by the order or zero order reaction? For the the reaction which are zero order, the rate is constant and the rate of such reaction does not depend on the concentration of your reactants. The rate of such reaction is not depending on the concentration of your reaction but depends on the other factors such as presence of catalyst. So your rate of such zero order reaction is not dependent on the concentration of your reactants but depends on other factors such as presence of catalyst. Now your enzyme catalyzed reaction can also exhibit a zero order kinetics. Okay, when is it exhibiting? When your concentration of your reactants, or you can say the concentration of your substrate, is so high that your enzyme is completely saturated with the substrate, or you can say enzyme is completely saturated with the reactant molecule. Measurement of enzyme activity. Now, usually your enzymes are usually present in very small quantities. So how will you know how much amount of enzyme present in that reaction? We measure your enzyme, how much amount of enzyme present by its catalytic activity. Okay, so we are measuring how much amount of enzyme present in a given reaction by its catalytic activity, and its catalytic activity is related to its concentration. Now there are two standard units to express your enzyme activity, or you can say catalytic activity. One is your enzyme unit and the other one is your catal. Now what is one unit? It is one enzyme unit is the amount of enzyme causing transformation of 1 micromole of substrate per minute at 25 degrees Celsius under optimal condition of measurement. Okay, and the second unit is catal, which is the accepted SI unit of enzyme activity. Now what is 1 catal? 1 catal is the amount of enzyme that catalyzes transformation of 1 mole of substrate per second. Now 1 unit is equal to 16.67 nanocatals. So let's summarize whatever we studied in this presentation. We saw that enzyme kinetics is a quantitative study of enzyme catalysis. We saw what is the rate of a reaction, what are first order, second order and zero order reaction. We saw how we measure your enzyme activity. We measure enzyme activity by its catalytic activity, and there are 2 units for measurement of your enzyme activity. What was 1 unit of enzyme, and we saw what is 1 catal of enzyme. Thank you very much.